following are examples of common calculations for the sample size. They are really elementary, not so complicated to understand basis behind the calculation. But usually, as I mentioned earlier about the method of sample calculations based on statistical methods being used, and usually the method of analysis end up with a statistical modeling. It's quite complex. So in real life, there are methods that's quite complex and really need to work as a team. But you can do it as well, as long as you understand about how to choose the method of analysis, and then the concept that I will show you in a minute. So here are some common method of analysis that we can learn about the concept behind the sample size calculation, and we can use to other settings as well. Get some idea from those methods, and then practice with your own research to understand. The first one is, if we have a research dealing with an outcome that is continuous and there is no comparisons, so it is mean for one group. And here is the formula that based on the parameter estimation. As you can see, there is no z beta. Again, the beta and alpha, we will talk about it in the last sessions of this lecture. So here is the formula for that research about estimating mean for one group. Like, what is the mean weight of the students? So n is the sample size that we aim to calculate. C alpha. So we divided by 2 means we aim to go for the two-tailed estimations, mean the confidence interval. For example, 95% confidence interval, we will get that in the two-tailed of the standard normal curve, and z is the standard normal coefficients. I will also show this at the end of the class. Like, we use 1.96 if the alpha or the type 1 error, we will talk about this later, is equal to 0.05. S is the standard deviation. S, this one, and D, this one, is the design precision level of, to express as half of the maximum acceptable confidence interval and or the width. Okay, so from the interval we divided by half, and then it is D. Okay, and then we calculate it by, as you can see here, we have this usually 1.96. If we want to have 95% confidence interval of the estimation, it can be like 2.58. If you aim for 99% confidence interval, but it's not common, so here is the most common one. And S is the one that we really need to have an idea about the variation. And D is the precision, so we vary this. This one is the expected standard error in our setting, so you can vary based on the literature or your settings. For example, here the literature could be about 27, you can use 25, 30, like that, 25, 30, like that. Or if it's 27 in the previous literature, you can 25, 27, 29, for example, for whatever that would possibly be in your setting. Then the second column, that parameters that has an effect to the sample size, a half it or the precisions, or plus or minus what. Like we expected to have the standard deviation of 5. What is the weight? If the weight is about 70, that means 70 plus or minus 5 here. Half of it. 70 plus or minus 5 here. It's become a confidence interval. So if this confidence interval, like 70 plus or minus 5 means 65 to 75 is meaningful, means you can imagine how the people with the weight of 65 to 75 look like. That means it's precise enough. Okay, you can, if you can tolerate up to 10, that means if the base evidence that would be is about 70, and if the mean weight is about 60 to 80, remain informative. That means you can imagine about the people with this weight, that's still meaningful. But in this case, I don't think so. That's some example of how we can vary this. And if you think in your settings, you can not achieve this much, but this one is too risk to end up with an inconclusive finding. But this one feasible, and it could be lead to a precise estimate. Then you can base on this and justify in your descriptions, which I will show you later. Before that, I will show you about if we base this sample size calculation on hypothesis testing, what the formula would look like. Here is the one. So any formula that involves Z beta, it will lead to the findings that is significance rather than the precision or the precise estimate or confidence interval. So here is some example. I will not go into details here, but to let you see some common parameters if we use it. This one is, again, we set the alpha is 0.05, therefore it's 1.96 as you see here. Sorry. Now for the Z beta, also the Z beta, there is only two common value. One is to aim for 80% power, which is the power is from 1 minus beta. This means beta is 0.2, lead to the power of 0.8, which is 80%. The Z is 0.84. But if we want to have a 90% power, it leads to 1.64. I will give details about how these numbers is from later in this class, and also the effect size. Okay, so even it end up with the sample size that ensuring significant findings, but there is not the p-value is not related to the size of the estimate. So be careful about this. I have a suggestion on how we're dealing with this later. That's for mean one group. And here is some example of the descriptions to justify the sample size calculation. Say a sample size of this 38 would be able to estimate a mean with a precision of 10, assuming a standard deviations of 30. According to a study, this need the reference. And you might elaborate more like that is based on the expected mean of 55. You can use reference that could be the one that you expected to arise in your setting. Then the 95% confidence interval of the estimate would lie between this and this, which is precise enough to answer the research question, for example. This is how you can justify your sample size. So I use this description based on this one. All right. The next example is if we compare mean between groups, say two independent groups, the formula is like that. So as you can see here, this is based on the hypothesis testing. There is a formula based on the confidence interval, but it's quite complex. So I will not introduce you here. After you understand this, you can search for the literature, what is that method, and you can follow that. But usually at the end, we calculate using existing software to help solving difficult issues of calculations that I will talk about it at the end. So let's see this formula. This is the sample size. So you need to know it is the whole sample size that you will divide it by 2, or this is the sample size for each group. So this is, there's some assumptions about what you will use. Here is assume equal size of group. Again, this represents the desired level. If you aim to get the confidence interval about 1.96 or the significant level of 0.05, you put here 1.96. This one is represent the desired power. Put it 0.84 for the 80% power, or 1.64 for the power of 90%. So there's two choices here, but this is usually one choice. And this components is a measure of variability for the continuous outcome. The sigma means that the variance, sigma square, is the variance. So you can get the standard deviation square to have this and multiply by 2. So this is usually the format of the sample size calculations. That means part of that is the standard normal distribution coefficients that correspond to the alpha and the beta error, and the measure of variation. Now the denominator is the minimum meaningful difference of the effect size. So usually we will review the literature for the control group and see how different that our experiment group could be. So this one is expected difference. I mean, make the difference that we would expect it, and give an idea about what mu2 would be. So only based on the literature for mu1, and this one is the expected difference that would be. It should be the size that is minimum possible, but still meaningful difference, because the smaller the difference, the larger the sample size we would estimate. So that means conservative scenario. So that is the largest sample size that could detect the smallest effect. Then we vary the parameters that we want to vary. For example, you could vary power. So there is two possible choices. Or you could vary mean in the control group so that you can have an idea about the minimum meaningful difference. Okay. So the mean group is 30 and the mean difference is about 10. How the sample size would be in 1 and 2, this is the equal sample size per group. Based on what? Based on the hypothesis of if mu1 minus mu2 is equal to 0, means null hypothesis, or there is no difference, and the alternative hypothesis is not equal to 0. You see, if we base this method on z-test, we need to base the method on statistical analysis. That means we will estimate the p-value based on z-test, because any statistical test always give the p-value. This test will have what assumption you need to specify, because if you don't want to vary. But if you want to vary this, it will increase more column, like SD1, SD2, standard deviation of group 1, standard deviation of group 2, that would be, you can vary. So you see, combinations of the parameters will give these tables a long table. And this is good to put in the appendix of the protocol to justify the sample size. And here is an example of justifications by putting the narrative paragraph in the method sections of the protocol, like total sample size of this in group 1 and this in group 2 would have a power of this 80% to detect the difference between groups of 15, assuming mean of 35 in control. As you can see here, I put in yellow color. Okay, and mention about the statistical, saying like the test statistics use two-sided, and issues about one or two-sided or one-tail or two-tail. We'll talk about in some class later in future. And here is an example of the sentence about the sample size calculations. End up with this, and then two or one-sided test, and at the end the significance level of the test is what? Usually 0.05. Proportions of one group. Okay, there is lack of z beta, so this is the parameter estimation based sample size calculation. Okay, just you see the common components of the formula, just like this is to represent the confidence interval, like 1.96 to get the 95% CI. Put it this P is the proportions, but put it in the decimal place like this. Proportions of what? Proportions of the outcome. That is the categorical outcome to calculate for the proportion that would be expected in your setting. And the desired precision D plus or minus some. So how many percent plus or minus what, like that. This is the direct estimate of the confidence interval. Varied the parameter again and justify the one that still meaningful and feasible, also possible to like this. A lot of judgment there, and describe it. A sample size of 400 would have 95% confidence between 16 to 24, assuming the prevalence of this one, according to the study of this, and if this is meaningful, conclusive, to imagine about the prevalence of something 16 to 24 is okay, that's enough, something like that, that's conclusive. Go ahead with this. If not, change it. Okay. Now, if we compare two groups, it's just similar again. Sample size for each group. The components designate about decide level of significance, power, and standard error. This one. So in continuous, we can see about the sigma. Here is the standard error, or the variations of the proportions, which is similar to standard deviation of the mean. Okay, so it's the same, right? You can understand now how common characteristics or components of the sample size calculation formula, and also this is the minimum meaningful and possible magnitude of difference. All right, this is for proportions to group. Then go ahead with tables that vary the parameters that affect the sample size and provide justifications that is smallest but possible and still meaningful, and under the scenarios that is conservative, to be safe when you finish the study and it still obtain the conclusive findings. Okay, these scenarios lead to, again, the descriptions like this: a total sample size of this in group 1 and group 2 would have the power of this to detect the difference between groups of 10%, assuming prevalence of 50% in control groups. According to the study, that we need that difference, and also at the end the test statistics and the significance level. So this is the scenarios correspond to tables that you vary this and put in the appendix of the protocol, and you could highlight this one to correspond to this justification.